Every YouTube video about Puma Punku tells you the same thing. The Tiwanaku had copper tools. Copper measures 3 on the Mohs hardness scale. Andesite measures 6 to 7. Therefore, carving these blocks with that level of precision was physically impossible. That claim has been repeated so many times across so many channels that it sounds like established fact. 12 videos in the last 4 months alone have built their entire narrative around it. There is just one problem. It is wrong. The Tiwanaku did not use copper. In 1998, Heather Lechtman at the MIT Center for Materials Research in Archaeology and Ethnology published a metallurgical analysis that changed everything we thought we knew about Andean toolmaking. She documented a ternary alloy of copper, arsenic, and nickel. Not pure copper at Mohs 3. A bronze alloy measuring 5.5 to 6 on the hardness scale, nearly as hard as the andesite itself. And the Tiwanaku did not just forge this bronze into chisels. They melted it. They built portable wind furnaces called huayrachinas that reached temperatures above 1,000 degrees Celsius. And then they poured liquid metal directly into grooves carved between massive stone blocks at Puma Punku, where it solidified into structural clamps designed to hold the entire platform together during earthquakes. They did pour something at Puma Punku, just not what anyone has been telling you. What follows is the story that no Puma Punku video has ever told. Not because the evidence is hidden, because nobody bothered to read the papers. The Mohs scale myth. The claim that Puma Punku's stonework is impossible always begins in the same place. Copper cannot cut andesite. The tool wears down faster than the stone. Months of work for a single groove. And the result would show irregular marks that look nothing like the smooth, machine-flat surfaces found on the H-blocks. But this argument collapses the moment you look at the actual archaeological record from the site. The Tiwanaku did not work with pure copper. Lechtman's analysis, confirmed by Andrew McFarlane using lead isotope tracing, identified the ore source as the Pulicayo deposits on the Bolivian Altiplano. The alloy contained roughly 95% copper, 2 to 5% arsenic, and 1 to 4% nickel. That nickel signature is diagnostic. It appears nowhere else in pre-Columbian South America. It is a Tiwanaku fingerprint. And before we go any further, there is something else about Puma Punku that every mystery channel conveniently leaves out. We know how the blocks were shaped. We have the experimental proof. It was published decades ago. 90 minutes with a rock. In 1996, Jean-Pierre Protzen, an architect at UC Berkeley, who had spent years studying Inca stonework at Ollantaytambo and Sacsayhuaman, turned his attention to Tiwanaku. He picked up a 4-kilogram hammerstone made of dolerite, a stone harder than andesite, struck a raw andesite block at a 15-degree angle, and watched a clean flake detach from the surface. 6 blows. That is all it took to produce a flat face on andesite. But Protzen did not stop there. He took 2 separate andesite blocks and fitted them together using nothing but hammerstones and a straight edge for checking contact points. 90 minutes later, the joint was tight enough to match the precision visible at Puma Punku and at the finest Inca walls in Cusco. 90 minutes, with a rock. That experiment is published and peer-reviewed. It appeared in the Journal of the Society of Architectural Historians, and yet somehow, across 12 videos uploaded in the last 4 months, not a single creator mentioned it. But the replication story does not end with Protzen. His colleague Stella Nair at UCLA took the experiment even further. Nair wanted to know whether the intricate decorative carvings found on Puma Punku's gateway blocks, the half-cross motifs and geometric friezes, could be produced with stone tools alone. She assembled a toolkit of flint, agate, jasper, obsidian, greywacke, quartzite, and hematite chisels. Then she sat down with a raw andesite block and started carving. 25 to 40 hours later, she had replicated a half-cross motif roughly 8 inches across. Same material, same tools available to the Tiwanaku, same precision visible at the site. There was exactly one feature Nair could not fully replicate: the perfectly planar interior surfaces where 2 carved faces meet at 90 degrees. That narrow gap in the replication record is real. Mainstream archaeology acknowledges it openly, but the distance between not yet fully replicated in a lab and physically impossible without advanced technology is enormous, and every Puma Punku video on YouTube treats that gap as if it does not exist. So if the stonework is not impossible, what actually makes Puma Punku extraordinary? The answer is not what they carved. It is what they poured into the gaps afterward. And this is where the real story begins. The pour that nobody talks about. When Lechtman examined the architectural clamps at Puma Punku under a microscope, she found something that separated this site from every other structure in the ancient world. At the nearby Akapana pyramid, the metal clamps connecting stone blocks had been cold-hammered from precast rod ingots. You could see it in the grain structure: elongated crystals, deformation lines at the hammered ends, the classic metallurgical signature of a smith working solid metal into shape. But at Puma Punku's South Canal, the clamps were different. The microstructure showed as-cast dendrites throughout the entire cross-section. Chill lines near the pour points where liquid metal first contacted cold stone. Irregular conformity to the hand-carved grooves in the stone surface. There was no hammering, no shaping after the fact. The bronze had been melted somewhere nearby, carried in a crucible while still liquid, and poured directly into matched sockets carved into the upper edges of 2 adjacent stone blocks. The metal solidified in place. It locked the blocks together, and it created a joint flexible enough to absorb seismic forces without cracking. To appreciate what that means, we need to consider the temperatures involved. Copper melts at 1084 degrees Celsius. Adding arsenic and nickel lowers the liquidus slightly, but you still need sustained temperatures above 1000 degrees to keep the alloy fluid long enough to pour and fill a groove before it solidifies. The Tiwanaku achieved this at an elevation of 3,850 meters, where the air contains approximately 40% less oxygen than at sea level. Combustion is harder. Furnaces burn cooler. Every metallurgical process becomes more difficult. Their solution was the Huayra Kaina, a portable wind furnace built from clay and positioned on exposed ridgelines to catch the strong Andean crosswinds. These furnaces used natural airflow instead of bellows, and they worked. Archaeological evidence confirms sustained operating temperatures between 1000 and 1100 degrees Celsius, enough to melt and pour ternary bronze with precision. If you are enjoying this, hit subscribe, because what comes next explains why one French chemist almost got the story right, and then missed the point entirely. The scientist who was almost right. In 2019, Joseph Davidovits, the founder of the Geopolymer Institute in Saint-Quentin, France, published 2 papers arguing that the stones of Puma Punku were not carved at all. He claimed they were poured, cast like concrete into molds using a geopolymer recipe 1400 years ago. His evidence was not trivial. He used scanning electron microscopy on stone samples from the site. He found elevated sodium levels in the red sandstone, 9.95 atomic percent versus 1.6 to 6.7% in candidate quarries. He detected organic carbon and nitrogen inside fresh interior surfaces of andesite, a volcanic rock that should not contain organic matter. And he pointed to a historical Aymara legend about a plant-derived substance that could soften stone. Davidovits had the scientific credentials to be taken seriously. He is the same researcher who proposed the geopolymer hypothesis for the Egyptian pyramids, a theory that remains controversial but has generated legitimate debate in materials science for decades. But his Puma Punku argument has a problem. Several problems, actually. The elevated sodium in the red sandstone matches a well-documented geological process called authigenic albitization, where sodium-bearing minerals form naturally inside sedimentary rocks over geological timescales. Davidovits himself conceded in his own 2019 paper that, with present knowledge, we cannot differentiate between natural authigenic and geopolymer albite. That concession, from his own pen, undermines the central pillar of his argument. The organic carbon inside andesite vesicles has a straightforward explanation. Over 1,400 years, microbial biofilm, fungal growth, and humic acids from soil infiltrate the natural gas bubbles in volcanic rock. This is routine in geology. It does not require a chemical binder. And then there is the physical evidence that makes the casting hypothesis impossible to sustain. Between the quarry at Kaliri in the Kimsachata Range and the Tiwanaku construction site, roughly 10 kilometers of Andean terrain, archaeologists have documented a trail of what locals call piedras cansadas, tired stones. These are partially carved blocks abandoned in transit. Some of them still have rope hold grooves cut into their surfaces for dragging. You cannot have piedras cansadas along a transport route if the blocks were cast in place at the construction site. The two explanations are mutually exclusive. Either the blocks were quarried, shaped, transported, and assembled, or they were poured on the spot. The piedras cansadas settle that question permanently. At the lakeshore port of Iwawe on the Taraco Peninsula, abandoned andesite blocks confirm the reed raft transport route across Lake Titicaca that Alexei Vranich, Harman, and Knutson reconstructed experimentally in 2005. The andesite came from Mount Kapia, an extinct stratovolcano roughly 90 kilometers away. It crossed the highest navigable lake in the world on Totora reed rafts. Davidovits published a Springer monograph in 2024, extending his hypothesis to Easter Island. His promised radiocarbon dating of the andesite organic matter, announced in 2019, has never been published. 7 years and counting. But here is what Davidovits almost got right. Something was poured at Puma Punku. He just looked at the wrong material. The bronze clamps that Lechtman documented are the real pour, the real evidence of in situ liquid phase construction, and they represent a pyrotechnical achievement that deserves to be understood on its own terms, not confused with a stone casting theory that the transport evidence does not support. Blueprints in stone. Now we reach the discovery that finally cracked the reconstruction puzzle that had defeated every researcher for 120 years. In 2018, Alexei Vranich, then at the University of Central Florida, published a paper in Heritage Science that did what no one had managed before. He digitized 150 years of historical field measurements, from Angran's sketches in 1848 through Poznański's astronomical surveys and Protzen's engineering analyses. Then he 3D printed 140 andesite ashlars and 17 sandstone slabs at 4% scale. When he physically assembled the printed blocks on a table, a coherent design emerged for the first time. The platform footprint was T-shaped, 167 by 116 meters. The blocks followed mathematical proportions with mirror image left and right pairs. Nested gateways created an optical effect where you looked through one portal into the next, producing an infinity mirror illusion carved entirely from volcanic stone. Two findings are critical. First, the dimensional variability among supposedly identical blocks is greater than mold reuse would produce. Every block is slightly different from the next. That is the signature of hand carving, not industrial casting. Second, Vranich identified a small architectural model at the site, called the Escritorio del Inca. It is a 0.5774 scale replica of a full stone ensemble. It makes no sense as a casting form, but it makes perfect sense as a master template guiding stonemasons at the quarry. The Tiwanaku did not need molds. They had blueprints. And underneath the entire platform, literally beneath the stones, Charles Ortloff's 2020 computational fluid dynamics study revealed a coordinated drainage system that most researchers had never fully mapped. 2 subterranean stone-lined channels, a perimeter moat, surface canals fed by canalized Corocoro springs. The system simultaneously managed rainy season runoff, post-rain ground drying, sewage flushing, groundwater stabilization to prevent foundation deformation, and irrigation supply. It is precisely inside these subterranean canals that the cast-in-place bronze clamps lock the stone blocks together. It was a pre-planned hydraulic network requiring leak-proof joints and seismically resistant fastening, designed before a single stone was placed. This was not primitive construction. This was systems engineering. 1 generation. Now the timeline. Recent research compresses the construction window in a way that makes Puma Punku even more extraordinary than the mystery channels claim. In 2023, Eric Marsh and colleagues published a Bayesian chronological analysis in PLOS-1 that recalibrated every available radiocarbon date from Tiwanaku. Their conclusion placed Puma Punku's primary construction phase within a window of approximately 580 AD to 630 AD. That is 1 generation, maybe 2. Not centuries of slow accumulation. A concentrated burst of engineering ambition completed within the working lifetime of the masons who started it. Vranich recovered a radiocarbon date of 536 AD to 600 AD from organic material in the deepest mound fill, consistent with Marsh's model. In June 2025, a team led by Capriles and Cala Maldonado published the discovery of the Palaspata Temple in Antiquity, the peer-reviewed journal published by Cambridge University Press. Palaspata is a newly excavated Tiwanaku gateway complex measuring 125 by 145 meters, located 215 kilometers southeast of the main Tiwanaku site. It was built between 630 AD and 950 AD, using conventional red sandstone and polished white quartzite. Palaspata proves something that changes the entire conversation. The Tiwanaku construction method was not a one-off miracle limited to a single plateau. It was a standardized, exportable, replicable masonry tradition deployed across hundreds of kilometers by provincial builders following the same architectural grammar. There is one more detail that should stay with you. Gonzalo Choque Condori, director of Bolivia's CIAAT Archaeological Authority, confirmed in September 2025 that only 5% of the Tiwanaku complex has been excavated. 95% of whatever the Tiwanaku built is still underground, waiting. Between approximately 580 AD and 630 AD, 1 generation of Tiwanaku engineers quarried 131-ton sandstone slabs from a mountain range 10 kilometers away and dragged them across the Andean plateau on ropes seated in hand-carved grooves. They ferried andesite blocks 90 kilometers across the highest navigable lake in the world on reed rafts. They shaped volcanic stone with 4-kilogram dolerite hammers, striking at 15-degree angles, then grinding and polishing with sand, water, and obsidian chisels until surfaces were flat to within fractions of a millimeter. They carved decorative friezes before installation, working with jasper and agate for weeks on each piece. They positioned these blocks on a T-shaped platform with subterranean drainage channels already engineered beneath it. They heated a copper-arsenic-nickel bronze to liquid state in portable clay wind furnaces on exposed Andean ridgelines at nearly 4,000 meters above sea level, where every fire burns cooler and every breath comes harder. They carried crucibles of glowing molten metal to the joints between stones, and they poured. The bronze filled the carved grooves. It solidified with dendrites conforming to every irregularity in the hand-cut channels. It locked the blocks into a single earthquake-resistant structure that has survived 1,400 years. And then, around 1000 AD, the Tiwanaku walked away. Their civilization fragmented. Their metallurgical knowledge was not passed down. When the Inca arrived centuries later, they looked at Puma Punku and attributed it to the gods. The Inca were not wrong about the scale of what they were seeing. They were just wrong about who did it. It was not gods. It was not visitors from another world. It was engineers, working in thin mountain air with bronze and stone and fire for one generation, building something that still sits on a windswept plateau 3,850 meters above sea level, asking questions that 95% of the buried evidence might one day answer. The real mystery of Puma Punku was never that we cannot explain it. The human explanation is more extraordinary than anything we could have invented. We have been telling the wrong version of the story for years.